Okay, let's see what's coming up with linear equations. So how you know an equation is a linear equation is the highest exponent is a 1. So if I give you x and you say, but there is no exponent, there is, because x to the first power would just be x. And so if you want to solve a linear equation, okay, so an equation has an equal sign, you might have something that looks like this, equals -3. And I want to isolate the d, get it all by itself. So to do that, I move this over there. Well, whatever you do to one side of an equal sign, you must do to the other. So to get rid of a -3, I could add a 3, and wouldn't that get rid of it? But I have to add it on this side as well. So it looks like I would get d equals -3 plus 3, 0. Now, you should always check your answers. So does d equal 0 make sense? Well, if I plug in d is 0, it looks like the left side equals the right side, and that does make sense. I know that's a simple way to start, okay, with these type of equations, but the big key is you always want to check these. When they get a little more difficult, let's say we have something like 3x minus 15 equals 0. I want to isolate the x. I want to get it all by itself. I always work on the x last, so I leave that for last. So the first thing I see is I could add 15 to both sides, because that's going to get rid of that. And now when I have a 3 times x, to get it off that x, I would divide both sides by 3, because notice what happens, 3 over 3 just becomes 1x, and I get 5. Again, if you take the time to plug this in to check your answer, so x is 5 is what I got, 15 equals 0, 3 times 5 is 15, minus 15 equals 0, and it does check. So always check your answer, even if it's just picking up a calculator real quick, to actually check it. And so lots of those in there. Let's get something that has a little more pieces here. So I have a 5 times 5c minus 1 minus 2 equals 22c plus 2. And as I mentioned, variables are just simply placeholders. This c could be for cost, right? We don't know. We're going to get to a point where we're going to have some actual word problems, but we don't really know, what this value represents. But we want to solve for it. So again, I kind of work, kind of see what's happening here. I probably would distribute this first. Okay, there isn't really a rhyme or reason to the order. You might say, well, why didn't you add 2 to both sides? You could. That's just what I decided to do. So 5 times 5c is 25c. 5 times -1, -5. And I bring the -2 down, and I get 22c plus 2 because I didn't do anything with that piece yet. So continuing on, I would collect these like terms right here. And again, as I mentioned, order doesn't matter, but I'm going to go ahead and make this look a little better. So -5 minus 2, they're both negative, so I'm going to add and keep the negative sign. 22c plus 2. And now from here, I'm going to move the 7 to the other side. So I get 25c, that canceled. I have the 22c still there, and now plus 9. And then I'm going to subtract 22c because I need to get the c's together on the same side. So I get 3c equals, that cancels, 9. and I am home free. I can now divide both sides by 3, and it looks like, if I can scroll, that I get my final answer of C equals 3. And what are you going to do? You're going to check it. So just very quickly, and when you check your answer, you always check it at the very first step. And the reason why is I could have made a mistake going down here, right? And so I am going to plug in 3. So 5 times 3 minus 1 minus 2. And the nice thing of checking is you can just pick up a calculator, right? Really quick. But I will do this, see if I can do this by hand. 15 minus 1. Remember that. Please excuse my dear Aunt Sally. And so 5 times 14 minus 2 equals 66 plus 2. And 5 times 14 is 70. And I get 68. And look at there. So this is the, I mean, you know, especially if you're taking a quiz, right? Because you want to know if you got the answer right. And you don't really need me to check it. You can check it. Now, I know you cannot wait to get to fractions. Yes, that was sarcasm. I know how much you love fractions. The thing that is cool about fractions, though, is there's an easy way to get rid of them. If you find a common denominator, and it honestly doesn't even have to be the least common denominator, and you multiply every single term by a common denominator, I think it would be 4. Watch what happens. It's like magic. So that cancels. This becomes 8. And now I have something I can solve very quickly, and x equals 3. Now you might say, but how can you do that? If you do it to every single term, right? You're not just doing it to one term and getting a common denominator and all that. If you do it to every single term, then there's absolutely nothing wrong with it. Even if the denominators aren't the same as they were in this case, I'll be lazy and I'm not checking that one. Minus 1 equals x over 7 plus 3. What is a common denominator? Well, I can just say 7 times 5 and do 35. Every one of these terms I'm going to multiply, and that's where you have to be careful. You have to do it to every single term, right? And so 5 goes into 35 7 times, so I end up with 7x. And then minus 1 times 35, minus 35. 7 goes into 35 5 times, so I get, put my equal sign there, 5x. 35 times 3 is 105. And now I just simply start moving things around. So plus 35, straight across there, 7x equals 5x, and I want to add 35, so that's 140 plus 140. Get my x's together, so subtract 5x on both sides. And so I get 2x equals 140. And finally divide both sides by 2. And I get x equals 70. So as you can see, it's kind of nice that it doesn't matter if you have the same denominators or different denominators, as long as you multiply every single term. Okay, every single term by a common denominator, then it looks good.